So moving on. So we can see this in this board level diagram, photo emission. This creates the primary photoelectron. Okay. And so here what we also create is what's known as a hole. So a missing electron from the core level. And we could get pretty hardcore into the quantum mechanics of what we call this hole pair situation. Okay, a hole pair situation is the electron hole that's created as well as the electron pair that relaxes back down into that hole. So we could get crazy hardcore into the quantum with this, but we're not going to worry about that for this class. Okay, and so what can also happen now in the X-ray photoelectron spectroscopy is secondary emission processes. And those secondary emission processes are very much related to this hole pair dynamic. Okay, so for example, you can see that an electron up in this level can relax down. Because that electron at a higher energy level is relaxing down to a lower energy level, that's going to give off some fluorescence, and that's going to be X-ray fluorescence. And this is very much how that aluminum K alpha source of radiation works. Okay, so this is how we get those X-ray photons in the first place. But now we can have secondary emission of electrons due to the instability created in this process. And those secondary electrons that are emitted are called Auger electrons. It's not Auger, it's the name of a French scientist. So it's an Auger electron emission. And so those Auger electron spectra can also provide lots of diagnostic things about our analytes. However, Auger spectroscopy gets ungodly complicated because you're dealing with all of these secondary effects. So the primary photoelectron is most useful in the characterization of materials.